Welcome back, guys. This is a video in the series Demystifying Machine Learning. Thank you for watching my videos. I'm Dr. Ganesh. So, a quick recap on the machine learning process. Machine learning process involves gathering data, cleaning data or data pre-processing, then selecting the machine learning algorithm which is suitable for your problem, and then run and get insights and then visualize. There are different types of machine learning algorithms: classification algorithms, regression algorithms, and clustering algorithms. We are seeing regression algorithms in this series. We have seen introduction to linear regression in 2 videos, and this is the last in that series on linear regression to explain about gradient descent algorithm. So, to summarize what is regression, there's a training set which is applied to a learning algorithm, and then the inputs are given to the hypothesis which is formed based on the learning algorithms and predict the output. The cost function will help us determine how far from our hypothesis the data points are. See in this picture, I have a hypothesis which is a straight line, red color straight line, and there are distances for different data points from the line, and by calculating this error, the distance, we will be able to understand how efficiently our algorithms are formed. So if we minimize the sum of errors for all points, we will find the best hypothesis. So to do so, we calculate sum of square difference between the output we predicted and the actual output y for all values. Then we divide this sum by 2 times the amount of training examples. So it will look like this: sigma h minus y the whole square over 2m. If we substitute h with the mathematical expression we defined earlier, which is ax plus b, it will become ax plus b minus y the whole square divided by 2m. Since we know the plane or the line that we form, so we know the parameters a and b, we know x, we know the output we got through that equation, we can calculate this cost. Getting the lowest cost becomes a matter of minimizing, and one way to do that is through a famous algorithm called gradient descent. So gradient descent is an optimization algorithm for finding the minimum of a function, and it is what we will use to find our linear regression. Let's consider for a moment that p equal to 0 in our hypothesis. Just to keep things simple and plot the cost function on a 2D graph. The cost function will consequently become dependent or solely on a, which means that in order to minimize it, we will have to find a way where a minimizes it. So it consequently becomes dependent solely on a, which means that in order to minimize it, we will have to find where a minimizes it. Remember the equation: sigma ax minus yi the whole square divided by 2. So to find the minimum of cost function, we are going to take a small step along the path of the function towards the minima. So let's denote it as alpha, a positive integer that indicates size of our step. For every step, we calculate the slope of the tangent in the function, you can see here, and determine which way to go. Should I go up or should I go down? Find the minima. If the slope of the tangent is negative, we increase the value of a. We will go to the right. If the slope is positive, we decrease the value of a. We will go to the left. Slope equal to 0 means we have found our minimum. If the cost is denoted by EA2, so you can see here, at some point if I start, I will keep going to the left or right according to where I started until I reach the least error point where the tangent gives me 0. So a simple gradient descent algorithm is repeat until convergence aj equal to aj minus alpha dou e a1 comma a2 over dou aj. This will involve calculation of b and a. So the hypothesis calculated while running gradient descent. To start the algorithm, we usually assign a and b to 0, which gives us the bottom line of the graph. Then for every iteration, the algorithm finds a better hypothesis, and alpha has to be chosen carefully. What will happen if alpha is too small? If alpha is too small, then gradient descent will take a real small step, so the algorithm will be really slow. What about a big alpha? If alpha is too big, it will miss the minima. It will step over, resulting in a cost function that increases instead of decreasing, isn't it? So if you imagine a 3D plane like this, somewhere you are right now, the gradient descent algorithm take you to the minima based on where you start from. If you start, so you see here a difference between the big learning rate and small learning rate. Maybe a huge increase in alpha will result in oscillating between different points, and it will take longer time to converge. What about smaller learning rate? That will essentially help you go down but at a slower pace. Because functions with more than one parameter, each parameter if you take independently, they may lead to different minima. So notice how cost function with more than one parameter, there can be multiple local minima where gradient descent can converge at depending on the starting point. Just like as we wander around blindfolded, we may end up in any valley which may not necessarily be the lowest one, isn't it? Just like, okay, so this is one of the problems of gradient descent. One way to fix that is by randomly initializing the parameters many times, running the algorithm for each term, each of them, and picking the parameters that gives us the lowest cost. So let's recap gradient descent. We formulate the hypothesis for the number of parameters and initialize all of them to 0. Then compute the cost function for the current parameters, compute the gradients of the cost function with the current parameters, and adjust parameters by subtracting the respective gradients. Repeat steps 2 and 3 until the cost has converged. If it doesn't, try adjusting the hyperparameters or having random initializations for your parameters. And that's it, you are done. So this is a simple introduction to gradient descent, and this primarily comes from for regression, and we explained linear regression in the last 3 videos, the last 2 videos and this video. Hope you are enjoying these videos. Please like, share, subscribe to my channel. And in the next video, let me brief you about logistic regression, which is a logical extension to linear regression and I hope you will find it interesting.